Okay team, I'm going to talk to you about differentiating trig functions today. So we're going to start with the function y equals cos of x. And we're going to talk about how to differentiate this. Now the differentiation itself is quite simple, but I really want to talk to you a bit about why it does what it does. So let's start by sketching y equals cos of x. Looks a bit like this. And of course that point there is 3 pi on 2, here's our pi, here's pi on 2, and here's 2 pi, and that's one cycle of a cos function. Obviously it continues on in both directions. Now remember, when we differentiate this, so our aim here is to determine what dy dx is. When we differentiate, we're actually finding the gradient function. So this is all to do with the gradient. So let's have a talk about what's going on with the gradient here. So let's start with our first point. Now at 0, the gradient, at x equals 0, the gradient is 0. So if we're going to plot points for our gradient function, that would be 0. And then at x equals 1, this has got a maximum gradient. And I'm going to tell you that the gradient actually turns out to be 1, but that's also a maximum, so that's important to us. What happens in here is the gradient's increasing like that. It is negative, so in fact it is negative, so I should move this down here. It's a maximum gradient, but it's negative. And it's slowly increasing to there. It looks a bit like this. And then at the point pi, we've got a gradient of 0 again. So it comes back up to 0. And then if we move along to the point 3 pi on 2, we'll get a gradient that's a maximum. So that's now actually a strong positive gradient, and it's our highest possible gradient. When we go back to 2 pi here, we're flat again, so our gradient is 0 again. You can see here we've actually got another periodic function from our original periodic function when we're investigating the gradient. And this periodic function itself is actually the sine function. Let me sketch that sine function. What function's on there now? It's the sine function inverted, just flipped over. And so that means it's actually negative sine of x. So right, cos x, when you derive it, goes to negative sine of x. And the same investigation will lead to, if y is equal to sine of x, then dy dx is equal to cos of x. Now there's actually a four-way cycle here, and so I might just write this up on the board. There's a little diagram that might help you with this. We start with sine x and cos x. When you derive sine x, you get cos x. When you derive cos x, you get negative sine x. And of course when you derive sine x, you get cos x. So when you derive negative sine x, you get negative cos x, and then when you derive negative cos x, you get sine x again. So this is our differentiation circle for periodic functions. And that's a nice easy way to remember it. It's a pretty simple rule though, and we can now take this and apply it to problems involving product rule, chain rule, quotient rule as appropriate, or real life problems where we need to know the gradient. Thanks.